So welcome back. Like I said a few minutes ago, good morning. Let's look at the remainder of charts. I think there's two types of charts left. There's yesterday we did line charts. Let me just go up a page here. Okay, sorry. So yesterday we did line charts. Um, Similar to scatter plots, but a chart that shows a line with an x and y axes, and on the axes it shows values that represent the data. So um, I wouldn't worry about it now, but in the future, if you missed yesterday's class, you can watch a review of that. Today we'll look at pie charts, and pie charts are exactly what they sound like. They look like a pie, but like a if you're not familiar with pies, I don't know how many pies you guys eat, because in North America they're pretty popular. Think of a pizza, right? Everybody eats pizza. And think of dividing the pizza into slices or pieces, and each piece displays some information. The thing about pie charts is it's a percentage type of calculation. The pie chart is used to display the sizes of parts that make up the whole. So the whole being the entire or 100% of the information. So if you had like the College of the North Atlantic, you had a pie, and like let's say, obviously that's not a very good picture, but you could have like men and women are enrolled at the college, and you could have like 70% and 30%. All right, that's a very simple example, but that's kind of what pie charts do. There's some debate in the mathematic or statistical community of how good pie charts are. They're very, very good for showing certain types of information, like if I wanted to show the relationship of men versus women, or like another example, you could have one of the population of Qatar and where they're from. So you could have people from Europe, people from Asia, people from North America, and put that on the chart. The key is it displays sizes of parts that make up some whole or entire piece. So example number 9, the pie chart below shows the ingredients used to make a sausage and mushroom pizza. The fraction of each ingredient by weight is shown in the chart below. So we see that half of the pizza's weight, so 0.5, also known as 50%, comes from the crust. Now, how do I know that? It's a white piece of pie. Like, look at the color, it's white. And it says here that the white part of the chart represents the crust or the dough, the bread. We see a quarter, 0.25 or 25% of the pizza weight comes from the cheese. That's a lot of cheese. And then you can see the remainder. We have sausage, tomato sauce, and mushrooms. Sounds like a good pizza. So interesting. It says if the entire pizza weighs 2 pounds, how much does the cheese weigh? A little typo there. Should just say weigh. So the graph here represents, the whole. So what we're saying is the entire pizza is 2 pounds. And I know 25% or 0.25 is equal to the cheese. So if the entire pizza weighs 2 pounds, then 2 pounds times 25% or 0.25. Remember, we use decimals when we calculate. We don't use the percentages. So that should just be a half. Yep. So 0.5 pounds of that pizza is cheese. That's a lot of cheese. Maybe, I think half of, I don't use pounds, or my brain and you guys are probably the same. Someone who uses the metric system, I don't know. I can't visualize that, but that's like, 225 grams of cheese. Seems like a lot. Okay. What about another one? Okay. So very similar pie chart here. Same type of pizza, but different ingredients, same type of chart. And actually same type of pizza, same toppings, but different ratios. And again, this is a ratio or percentage type of situation. The pizza here is weighing 1.6 kilograms, and the chart shows a little bit different information. The label here no longer shows the fraction of pizza made up by the ingredient, but the actual weight of the ingredient. So this is like a ratio or recipe. There's a lot of words here. I'm not going to read the whole thing, but it mentions to get the fraction of pizza made up by any ingredient, we're going to need to divide the ingredient by the entire weight. And what I mean is, there's a question here, what percentage of the pizza is sausage? Well, my ratio of sausage is 0.08 kilograms to 1.6 kilograms of pizza. That's my ratio. Yeah, make sure. So if you're wondering where the 1.6 comes from, it's here. You could also get the 1.6, guys, by adding up all of these. Okay, so you could add up all those numbers to get 1.6. But if you're wondering where the 1.6 comes from, it's in my question. So the percentage is just going to be, and again, think of like when you get a grade on the test. Say on the test on Sunday, you get 25 marks out of 30. Well, we could easily calculate the percentage. So if I have 0.08 kilograms of cheese out of a total of 1.6 kilograms, we can find the percent there. Now, very important thing, guys. This is not a percent. What I need to do, and this is review. You guys know this. We did this in chapter 3. I do need to multiply that by 100. So 5% of the pizza is sausage. All right. And by the way, my personal opinion, I don't think pie charts should be made this way. If you were presenting something, if you were sharing information, so maybe in the future you guys are going to give a presentation to your colleagues, to your friends, or not friends, but your teacher and some of your students, your fellow students, friends, I guess. This is not really how I would represent a pie chart, because you're making people do the calculation. Again, I didn't make this book, but I do have strong opinions on charts. I think this is a much more useful pie chart, because instead of showing the ingredients for one pizza, it's showing the ratio for every pizza. Okay, so I don't know. That's my personal opinion. All right, anyways, let's look at another one. And hold on, let me see how many examples there are, because I might get you guys to try a couple. Oh my gosh. Okay, there's 2 more examples. So I'll get you guys to try these 2. I guess I could just use the page up, page down button. Okay. So I'm going to get you guys to try this one. Now, again, this is my personal type of pie chart. It's giving the percentages. So the pie chart below, again, shows the ingredients used to make this pizza. The fraction of each ingredient by weight is shown. So this is a weight percentage here. Okay. Again, we do see that half the pizza's weight, 50%, comes from the crust. And the rest of the percent sizes are there. And you'll notice if you add them all up, they will equal 100%. A pie chart has to equal 100%. Um, I did a course recently for another program. I'm a student as well. I'm doing some other coursework. And one of my courses was kind of about infographics and information. And sometimes on the internet, you'll see fake data or misleading data where the pie chart does not add to 100%. So you have to be always aware of how any chart or graph is labeled. There's a lot of misinformation out there. Oh, and this isn't a question. This is just an example. There is no question here. So, okay, I think there's a question here. Yes. All right, I'm going to get you guys to do this one. So the pie chart below is a different one now. We're not talking about pizza anymore. This shows the fractions. So a fraction is a percentage represented as a decimal or fraction of dogs. So it's like percent. Of dogs in a dog competition in seven different groups of dog breeds. So I don't know. It's easier for me to just look at the graph instead of reading a big paragraph. I can look at this graph and tell exactly what it means. Well, the graph would need a title, so it would have to say, um, groups of dog breeds in a dog competition. That would be the title. And then I know that with this purple, I have the sporting group, so kind of sport dogs. In the dark purple, I have a working group. So 21% of the dogs in this show are from a working group. I don't know anything about dogs, by the way, so I don't know what the difference between a working group and a hound group is. I'd say like a working group are like the ones that herd sheep, and hounds are ones that hunt animals. I don't know. So this tells me everything I need to know. So if you ask me what percent, oh, I was wrong about the working group, herding group. What percent of the dogs were herding? Well, I look for the green piece, 0.06 as a fraction, or 6% of the dogs in this competition were herding dogs, so like a border collie or something. Okay, so you can figure out the number of dogs in any group here by multiplying the fraction of the number of dogs in the competition. And in this question, it says, well, what if we had 1,000 dogs? How many, oh, sorry about that, the noise. How many dogs, if we had 1,000, would be in the toy group? I'll get rid of my writing here. So in the toy group, we have 1,000 dogs. 12% of those dogs are in the toy group. I think toys would be like the one you see in people's like handbags. So like, I don't know, Shih Tzus and all those little tiny dogs, toy poodles. I would take the fraction, so 0.12, and multiply it by 100. So I'd get 120 dogs. Cool. So I would like you guys to try one. Pie charts are not really like, between us, if I could know two charts, it would be the line chart and the next chart, the histogram. But so I'm not focusing too much on pie charts here because they're not my favorite. If I could know two charts, wink wink, it would be bar graphs and line graphs. But this is a good question. So very quickly, I'll just give you 1 minute for this. Let me zoom in one more. How many of the dogs are in the working group? So working, if your screen isn't a very good color, working group is this group. Okay, so there's 1,000 dogs. And I'll just give you 1 minute. Tell me how many are in the working group. You can put it in the chat. It should literally take you 10 seconds, but I'll give you a minute. Yes, perfect. Okay. I was nervous for a second because I wasn't getting any answers. And you know, I won't say it's early, it's 9:30, but it's late in the year, late in the semester. I know everybody's getting pretty tired here, but that's perfect. So Kalsum and Zarina, Reem said 210. That's perfect. So 0.21. Again, just remember this represents 21%. And the reason I mention that is because in the future, most graphs you will see will be percentages. Again, not my favorite type of graph, but 0.21% or 21%, 0.21 of the dogs are worker dogs. There's 1,000 dogs, so 210 of them. Excellent. Easy. All right, let's move down. Now, just give me 1 second. Oh, histogram. Okay. Oh my gosh, this is perfect. There's only really 2 pages left that I need to do because I want to show you bar graphs and I want to show you histograms, which are like bar graphs, 3 pages. And guys, this topic is the finale of this course, markup and discount. We'll save that for Monday. And we should be able to do this on Monday. Again, I don't want to give you too much information today. So let's look at 2 more graphs and then halas. That'll be enough for this morning. And again, I highly recommend after class today and tomorrow, you guys start practicing chapter 3. So bar graphs. Bar graphs have, well, they're like a line graph. They have an axis. They have horizontal and vertical axes, so X and Y, that show different values. The thing about bar graphs is they can be horizontal, meaning like they can go this way, or you could have a bar graph that goes up and down. Now, this is a histogram. This is a little bit different, but still the same type of information. I'll explain that in a minute. But this is a horizontal bar graph. The bar chart here shows the weight in kilograms of some fruit sold one day by a local market. Okay, let's look at this. Papaya. Man, I haven't had a papaya in a long time. Papaya, I love these charts because these are probably the easiest of all charts to read because there's no real numbers or crazy calculations. I just say, okay, papaya. I go down on the line. It's right there. So this is 10. I think every line here would be 2. So 12, 14, 16, 18. Yeah. So if I'm here, I would have 10, 12, 14, 16 papayas. Every line is 2. Let me zoom in and show you that. So like 40, 42, 44, 46, 48. Okay, so every line is 2. That's one of the only things that you'll need to do or need to think about. So my papaya here is at 16. Apples, 52. Right? I mean, this is a really easy chart. And you guys have, I hope, done this at some point in your school, or you're not too surprised by this type of chart. So there's a question here. It says how many mangoes were sold. So mangoes, I go over to the end, I draw a line down. You don't need to draw any of these lines, by the way, but it's 22, 24 kilograms of mangoes were sold. I don't know if this question gives me any more information. No, okay, that's it. So this is kind of a weird question. It should actually say how many kilograms of mangoes were sold, because we don't have any information here to figure out how many mangoes were sold. Like as a number, I can't say like 10 mangoes were sold or 30 mangoes were sold, but I do know that 24 kilograms were sold. If I knew like the average weight of a mango, I could make an estimation here, but I don't have the information, so we don't need to worry about it. But I will say that that question should say how many kilograms of mangoes were sold. Okay, pretty easy. All right, a histogram. You might see a histogram on your final exam, maybe. Wink, wink. Cough, cough. um, I can give you and help you guys with your exam a lot more now in the future because I have made it. It's complete. I submitted it for review. So I kind of know what's on it now. So when we do review on Thursday or when we do, so when we review test 3 on Thursday, I can also tell you some things that you should know for your final in chapter 3, because chapter 3, I think, is the hardest chapter. And then on like Tuesday or Wednesday, when we do review, I can give you hints on the rest of the chapters. I think what I'll probably end up doing is on Wednesday or Tuesday, like I'm hoping to start the review on Tuesday, but I think I'll focus on chapters 1, 2, and maybe a bit of 4, because hopefully after Thursday and Sunday your test, you'll be pretty comfortable with chapter 3, but it is the hardest chapter. So we'll see how it works. I'm very open to whatever you guys want for a tutorial. This, by the way, I'll finish this up now in a second, but this might be my favorite course I've ever taught in intercession. Intercession is very hard to teach and very hard as a student because like in Math 1700, my classes are an hour and 45 minutes every day, non-stop. It's crazy, but this is so relaxed. Like, we're going to finish early basically. So I like this course. I hope you guys enjoy it too. I do know chapter 3 is tough, but I think 1, 2, and 4 are quite doable. Anyways, so histogram. You might need to know this, or you might see a histogram again. This is like a bar chart, but it's organized differently. So in the above bar chart, we had very specific examples: papaya, mangoes, apples, just one type of fruit. This could be types of cars in Qatar. So you could have Toyota, Nissan, Honda, Mercedes, BMW, whatever. Very straightforward. Histograms are a little different. Sorry about that. This is where a graph has different classes that are marked on the horizontal axes. Horizontal goes this way, and the frequencies are marked on the vertical. Vertical goes this way. Now, frequencies are the number of times that they appear. The class is like a grouping. So let me give you an example. Like this is not a good example. This one right here. Even this, not the best example. This one is a little bit better. But let me give you another example that I could do. We could make a histogram. Oh, and sorry, let me see the chat before I go further. Oh, thank you, Samar. Very, very much appreciated. Let me give you an example to kind of get your heads wrapped around what a histogram is. What we could do is we could make a survey of every student at the college, and we could group them in ages. So, like, have you guys ever done a questionnaire or a survey where it asks you to check a box that represents your age? So it might say 10 to 19, then it might say 20 to 29. Then it might say 30 to 39, 40 to 49. That's what we would call a bin or a class, like a grouping. The frequency, so this is my grouping. I think in Microsoft Excel, they call it the bin, but this is my grouping. So this would be, you could think of this like ages, for example. This is just an example. So you could have people age 10 to 13. So 10 and less than 13. Then you could have 13 to less than 16, 16 to 19, 19 to 22. And the frequency is how many of those classes you have. So again, think of the college. How many students at the college between 10 and 13 do we have? None. Well, I don't think so. How many students between 13 and 16? We might have like 1 out of 2,000 students, maybe 5 people who are just or almost 17, but they're still, no, sorry, that wouldn't work. Here, we'd still probably have 0 students. But now here, we'd start getting more students. So students age 16 to 19, we might have 500. 19 to 22, we might have 1,000. 22 to 25, maybe 700. That's just an example. In this chart, it doesn't really give us much information, but it does say in the grouping of the number 10 to less than 13, so like 10 to 12.9, you would have 5 samples or 5 like things that represent this part of data. In the grouping of 25 to 28, you have another 5. In 19 to 22, you would have 21. All right. Now, one thing. If you're wondering where these percentages come from, it's very, very easy. There are 80 people total, 80 total things. So if I wanted to find, oh, I don't know if this is actually calculated right. Yeah, it is. Okay. It's just rounded a little differently. So if I had 5 people or 5 samples out of 80, that's 6.3%. It's actually 6.25. 21 out of 80 would give me the 26.3% that I'm looking for. I'm just letting you know where the percentage came from. I'm taking the frequency from the total. So this is a bit of review from chapter 3 in a way. Now, you guys know me. I don't like tables, well, I do secretly love tables, but if I could choose, I would much prefer this information on a graph. To me, this is much easier represented. So in the grouping from 18, or sorry, that's a 6. Sorry, guys, not a very nice graph. 16 to 19, I have 24% of the things. Again, it's not telling us what these things are. It could be people, it could be the, whatever. I don't know. It could be marks on a test. I hope not. But this graph shows us how many. So if you were very quickly asked with this histogram, what grouping was the smallest? Well, easily I could say that the smallest group was 31 to 34. The largest group was 19 to 22. So it's a very, very, very quick, like, again, if this was ages of students at the college and somebody said, well, what's your main grouping of students at the college? What's your main demographic, you would say? You could 2 seconds look at this chart and say, well, most of the students at the college are between 19 and 22. Easy. Right? So again, that's why I love charts. You can just so quickly look at an answer. So guys, this is it for today. We're gonna do this example. We're gonna look at some questions and then halas. And this is a very, very good example to know. Wink, wink. Okay. The following histogram shows the number of employees versus the salary that they make in thousands of dollars. So little quick review of what this means. The number of employees, so here, let's say about 50 employees, they would be your lower end of the salary scale. This is dollars. I know it's dollars because here, and it's in thousands. So what this means is this grouping would make 0 to 10,000, which means 0 to 10,000 like this. Okay, the reason it's written as thousands is so we can fit the numbers on the graph. So around 50 employees are making less than $10,000. Almost 550 or maybe 550, there's a bit of guessing here, make between 44 and $54,000. So this grouping would make 44,000 to 54,000. Okay, this is what the bar graph is telling me. But what are my questions going to ask? Okay, well, we already actually answered number one. Let me just get rid of some of my writing here, clean it up. How many employees make $10,000 or less? So that's this group would be about 50, right? It's not 100, it's not 0, it's in the middle, 50. If on a test or final you said 60, if you said 55, I don't care. I do feel that it's really in the middle, but I mean, I'm not gonna, between 45 and 55 are good answers. I wouldn't worry about being too precise. Okay. Oh, that's a tough one. Oh, that's a lot of work. Okay. I I am going to show you, no, we can do more review on, because this is the end of graphs, by the way. So like next day when we're on Monday, when we do new things, we're starting a totally new topic. So this is really the only question. And I will do number 2 for you. And then I will do number 3 just because it's such a long question. So let me do 2 and 3, and then you guys can do 4, and then that's it. And we can do more review on this when I have a sample final exam that will have a question like this. We can look at that. If you guys feel you need another histogram, and there isn't one in the notes, I have another that we can look at later. But let's look at this. How many employees make more than $65,000? All right, I'm going to get rid of my writing here, just so I start with a nice clean graph. I will keep the about 50 here. So more than 65, right? More than 65 would include this guy, and this guy. Oh, so this is the tough part. Now what we need to do is we need to estimate how many of each of these we have. All right, so let's start at this one here. Here is 100 employees. Okay, I can tell it's easier if this is on paper, but we have 100 employees here. All right, what about in the next grouping? Well, this is about halfway. So here we have 350 employees. If anybody doesn't know where I'm getting those numbers, let me know, but they're coming straight from the chart. Now this one, is it halfway? I'm just gonna go this way. Yeah, let's keep it simple and let's keep it halfway. Honestly, I think it might be 260, but let's keep it simple. Let's say 250. The reason I'm not being too picky is because this isn't a very clear graph. Like there's no like divisions in here for me to see. So I think 250 is okay for that. Although I really do think it's 260. But yeah, anyways, Calcium. Oh, Calcium, you said 710, so you must have said 260. I agree with you, man. I gotta change this to a 6. My heart is telling me to make this a 6. But guys, I don't care if you did this on just I would not take off marks if you said 260 or 250 even, or even 275. I mean, as long as you're close. So we have 260 plus 350 plus 100. And that's it. Now, Calcium said 710, so let's just make sure. Yep, perfect. 710 employees. Okay. The next question. how many employees are there? Now, I'll tell you this. um, if you saw one of these on your final, you might see one. So if you saw one of these on your final, your instructor might be kind enough to put the numbers on top so you don't have to do this part. So just a little hint for the future. This number, like 100 and 350, they might be included on the graph. Wink, wink. So you might see these numbers and you won't have to actually calculate them yourselves. So I just have a feeling that this one is around 440. This guy, I'm just going to say 550. This guy, see, I love this, 400. This guy is halfway, so I'm going to say 250. 350. Okay, so now I can add all of these up for question 3. And I'm going to zoom out. I do apologize that it's small. So I'm just going to add up all of these numbers. And I'm going to be lazy, guys. I'm not going to write this down. Like, I'm not going to write all of these numbers added together. What I'm doing is adding up the tops, so 50 plus 300 plus 250. I'm adding up all of those. And what I end up getting is 2,700, about, right? Key word here. $2,700 employees. Now, I've done the hard work for you because I've already calculated all the employees in every bin or category. So my last question for today, how many employees make less than 88,000? Okay, so 88,000 being here. So how many employees make less? You guys, actually, this is easy because if you know the total, 2,700, there's a really quick way to calculate this. So what do you guys think? How many employees make less than 88,000? Yeah, I'm getting answers already from everybody. Asma, Kalsum, Maka, Samar, everybody's answering because I hope you did what I did. A lot of you guys are probably tempted to just add all of these up again, which you can. I mean, there's no problem with that. But if I know that there's 2,700 employees and I just take away the last group, it would give me 2,600. For anybody who doesn't get that, you can just add up all of these. It's more work, but I don't care, right? Like if you do this on a test, for me, it doesn't matter how you get the answer as long as you didn't cheat. But that you guys don't cheat, that won't be an issue. So thank you, Reem and Aisha as well, and everybody else. I said, Samara, Maka, Kalsum, Asma. That's great. Guys, that's it. I'm going to end it there. We are in a very good place to finish this course on Monday. Might have to do a little bit on Tuesday because there is about 10 pages left, but it's not as crazy as it sounds. I will warn you, though, on Monday's class, we are going to look at new formulas, but it's very easy. These formulas are in your data sheet. Very basic kind of business math formulas, and we are going to look at them on Monday. Again, we might need a little bit of Tuesday to finish, but that'll leave the rest of Tuesday and Wednesday for review. I think you guys, your exam is on Saturday at 8 a.m. I don't think I've ever had an exam on a Saturday, so that's it. That's all we can do. But yeah, your exam. We'll do this on Monday. We'll review tomorrow, and we will have your test on Sunday and finish this course up by Monday. All right, guys, if there's any questions, let me know. I'm going to hit stop record, and I'll see you guys tomorrow for the review.